I like to introduce Joren van Hemelrijk, and I will read it. Joren is a certified AWS developer and leads the server-side team at November 5. In his first years, he built up experience building backends using PHP, thank you, PHP, on a traditional AWS stack. The past 3 years, Joren led November 5's move towards serverless development. In his years at November 5, Joren built backend applications for clients like Coca-Cola, Anderlecht, and Le Pain Quotidien. So, without further ado, choreography and orchestration in a serverless world.
Thank you. Maybe first, is it clear? Is my voice clear for everyone? All right. Great. So indeed, I'm going to be talking about choreography and orchestration in a serverless world. Fancy words, but along the way, you'll understand what we mean with this. First, a little introduction. So my name is Joren van Hemelrijk, server-side and DevOps engineer at November 5. Quick introduction to November 5. We are a full-service digital agency. We build custom digital solutions to keep your business in the lead. We do this across industry, across technologies, and across industries. I'm quickly going to make sure I can see my presenter notes. Excuse me for that. All right. So, and yeah, little small thing as well. As all companies, we are also hiring. So, sorry for that. So, a little introduction. First, I'm going to try to set the scene of this presentation by using a little story, just so everyone can follow. So, we have a fictional company called October 4. It's the name of our fictional startup. We run a web shop selling these awesome stickers. And there's a few actors in this story. We have the boss, we have the developer, the Rudy, and we have a printer. Just for the sake of this presentation, let's assume that this is a magical printer that will never run out of ink, never run out of paper, will never jam, a non-existing printer. So, one day at the office, the Rudy and his boss are in, and his boss asks him to write a little program to send all of the webshop orders to their shipping partner. Except if the shipping address is in Antwerp, because we're based in Antwerp, then we will deliver the packages ourselves. And in that case, just make sure that we print the shipping label on our office printer. And Rudy is like, okay, I'll just write up a quick Python program that captures the Shopify webhook with the order confirmed. And then I will just do all that stuff. The next day in the office, again, his boss and Rudy. We all know that our bosses can change their mind very quickly, and so the next day is about, he asked him, like, about that program you wrote yesterday, make sure that it can handle like a lot of orders, a lot of them, because of course, yeah, if a lot of people buy stuff, we need to be able to manage that. And it's gonna be Black Friday soon, so it needs to be able to handle a lot of orders. Oh, and yeah, by the way, don't go overboard with servers because, yeah, we're still a startup. We don't want to spend a lot of money on it. So, yeah, just make sure it doesn't cost that much. Yeah, the Rudy is like, okay, I'll just copy-paste my Python script into a serverless Lambda function that he's heard about someday. He heard that it scales infinitely, and that will solve all my problems. All goes well until Friday, of course. Again, they're both at the office, and his boss is like, Rudy, come on, man, you idiot. All the shipping labels have to-do address here on them. So, yeah. I want this fixed by Monday, no excuses. And Rudy is a bit, yeah, confused because he's like, oh, damn it, I forgot to change that to-do. And I can't re-trigger those webhooks. They went in, we handled them, and now all the shipping labels are printed. So, damn it. The boss doesn't care, of course. Monday fixed or you're fired. Also, once the labels are printed, mark them as shipped in Shopify, and also send us a little Slack message in our parcel delivery Slack channel, just because he doesn't have a lot of stuff to do. So yeah, he can just take that as well. Rudy is, yeah. He needs to fix this, and properly this time. So over the weekend, the Rudy decides to go on a serverless journey throughout the whole weekend. So maybe first a little checklist to go over the requirements. So we have the classic Python script, and the requirements are the following. So it needs to be auto-scalable. If a lot of orders start coming in, we want, of course, that these orders can be handled, and our servers won't go down or whatever. It needs to be cost efficient. We're still a startup. We don't want to pay for idle time, or when we don't have a lot of orders. We don't want to pay for that. Then it needs to be extensible and maintainable. We don't want to have spaghetti code all over the place. And it needs to be replayable. Like you saw, he had all the orders were marked as to do. So yeah, we want some way to re-trigger all those webhooks somehow. So I'll quickly go over the serverless concepts. A lot of you might already know what serverless is about, but just for completion of this presentation, I'll quickly go over some core concepts. So where we started, or where we sometimes still are, working with physical machines that can go down. We went to virtual machines, then containerizations. They're all solving specific problems, but now serverless is like the next step there. You basically focus a lot on your business logic. You write your code, and you use existing services that cloud providers give you, and glue these together with your business logic. You also only pay for what you use, and that's basically what serverless is all about. A few core concepts are that it's hostless, it's elastic, it can scale out without having to do a lot. It's stateless, you're building with Lego blocks, you're really using services that exist to actually glue them together with your own business logic. And then the usage-based cost is also one of the big things. You only want to pay for the compute time and the CPU time you're actually using. So that's a very good, very nice one. So because of all these characteristics, you are inside an event-driven architecture. This is a very complex image and very chaotic, and your architecture might also become very chaotic. So we need some tools and some concepts to actually make sure that it doesn't become like this image, and you can actually grasp what is happening inside your application that you're building. So without a plan, serverless and serverless technology and architecture can become very tricky. A few things. So your architecture in general can become very complex. Your error handling can become very complex because you're working with a lot of distributed services. They're all over the place. Your code is kind of all over the place. So it can become very hard to do error handling. Monitor and debugging, also another one that might become very hard. Again, very loosely coupled services can become very hard to actually follow your request or whatever throughout the whole flow. And integration testing is another one. Again, lots of services can become hard to test all of them throughout this. So we need some tools and some services that can help us with that. If we go back to the checklist, putting all this Python code inside a serverless Lambda function already checks two of those. It's auto-scalable and it's cost-efficient. A Lambda function, you're also only paying for what you're using. So if there's no orders coming in, you're not paying for compute time. But there's still the two other ones. It's not really extensible or maintainable. It's one big block of code, and it's not replayable. Still, like the orders or the labels are printed, and yeah, they're out there. So this sounds very cool, like the concept to actually make those two check marks be checked, but the Rudy doesn't know where to start. So here we go with choreography and orchestration. Those are the two main concepts that will help us to actually make sure those two check marks are also checked in our serverless setup. So, orchestration. You should really look at orchestration like a symphonic orchestra. There is one conductor which will actually tell separate components what to do. And it controls the execution order. Then you have choreography, just like a group of dancers dancing to a beat or a piece of music. Each and every dancer can dance independently to that specific piece of music. So they don't have to do everything all the same. Each and every dancer can have their own responsibility. So those are quickly what choreography and orchestration are. Some advantages and disadvantages of both are, for orchestration, it provides a very good way to model your workflows. It's really like a tree diagram where you can follow where your request and everything is going. It's also very easy to understand and very visual in most cases. There's some disadvantages as well. You have higher coupling between your components. And also your orchestrator is a single point of failure, so you really need to make sure that that is on point. When do we use orchestration? We use it across, we use orchestration inside microservices. This will become more clear along the slides. Choreography, the advantages are that it's very easy to add and remove components. It's very plug and play. And one of the core advantages is that it has replayability. That's also something I'm going to show you in a bit. And the disadvantages are the asynchronous nature requires like a mind shift. A lot of serverless stuff is very asynchronous, and you really need to think about stuff differently because it's asynchronous and very loosely coupled. And because of that, it can also become very unpredictable. When do we use choreography? We use it to coordinate across microservices. So orchestration is used inside microservices, choreography across microservices. And both of these together make for a successful serverless architecture. A very small thing when we're talking about orchestration, choreography, and serverless in its whole is item potency. A very small intermezzo about that. Item potency is very important. Some of you might already know what that is. Quickly going to explain it. Item potency means that when a certain event or a certain thing happens once or multiple times, the end result will always be the same. The picture here illustrates that with Harold mowing the lawn. If your grass is like 10 centimeters high and you go over it with your lawnmower, it cuts it to a specific height, let's say 2 centimeters. If you keep going over that same patch, it won't get shorter and shorter and shorter every time. It's just set to a certain height, 2 centimeters, and it doesn't matter how many times you go over it, it is cut to that amount. That's an idempotent action. If you do it once or multiple times, the end result, the height of the grass, is going to be exactly the same. That is also something you need to keep in mind when you do serverless in general, because of its asynchronous nature, and also a lot of services have an at least once delivery, meaning that a certain event can be fired once, or in some cases twice or 3 times, because of its, again, the asynchronous nature. So you really need to keep that in mind when writing code. So that's a small intermezzo about idempotency. Now, choreography and orchestration. How do we leverage a cloud provider like AWS? You also have Azure and Google Cloud and other cloud providers, but we at November 5 use a lot of AWS. I'm going to show you how you can leverage those inside AWS. The orchestration tool inside AWS is called AWS Step Functions. It has fully automatic scaling. It can run up to 5 minutes for express workflows or even a year for standard workflows. And you also pay for what you use. I'm going to show you in a bit. It's a tree structure, and you only pay for whatever you're doing inside that step function. Just like this, it's basically a diagram, and you have a start and an end. And then you have steps in between, which can be Lambda functions or triggering other AWS services. And and you're only paying for what you're doing and for the state transitions. You also have built-in retry behaviors. So if any of these steps will fail, you can tell it like, okay, send us a Slack message or an email message to let us know that something went wrong. The choreography tool choreography tool in Amazon is EventBridge. It's a fully automated and scalable event bus. It has built-in archive and replay capabilities. This is a very important one for one of our check marks. I'll give an example later. It also has native integrations with a lot of software as a service providers, just like Shopify, Zendesk, or a lot of other providers. So you can really just hook it up to Shopify, and it's very easy to capture those events. And you, again, only pay for what you use. If no events are coming in, you're not paying for anything. And even if they are coming in, you're only paying $1 for every million events published. A little example for that is, you have event sources in your EventBridge, you have event targets, and then you have custom rules in between those to actually guide your events to the correct places. So let's say a Shopify event happens, you tell it if this and this and this is inside this order, let's send it to, for example, a step function in our case. And of course, the one that everyone knows about is AWS Lambda, the functions as a service implementation of AWS. It has native support for a lot of languages like these. It has automatic scaling, and again, you're only paying for what you're using, which is dirt cheap. You're only paying 20 cents per million requests, also depending on how long your Lambda function is running, but it's very, very cheap. Rudy knows what to do now, I'm gonna quickly show you how you can bring all of this together with a few small examples. So inside EventBridge, you can actually have, if these are the event rules, so an event pattern, you can actually say it if a Shopify event comes in, the shipping address, the postal code should be 2000, and the city is Antwerp or Antwerpen in this case. Then we can send it to our state machine, a step function, to actually handle this specific use case. The step function itself might look a little bit like this. You have a few steps. The first step would be sending it to our printer to actually print the label. And then you can have parallel steps. The first one might be do an API call to Shopify to tell them, hey, we're actually shipping this product. And the other one might be, let's send a Slack message to notify us as the company, okay, this order is actually updated to shipping. This is a little bit of the final diagram. It's a little bit simplified, but still the main components are here. You have Shopify, an event happens, an order is placed, it goes to EventBridge. The EventBridge rule will actually send it to our step function, and inside the step function, it will orchestrate and say, okay, first the shipping label needs to be printed, and then those two other steps. So this is kind of how choreography tools and orchestration tools go hand in hand to actually make this very readable and very maintainable. If we go to the cost breakdown of all of this, this is also very nice. Let's say in the first month, our shop is not doing that great. Of course, we're still new. We have 10 orders, which is almost nothing. That will mean that we invoke around 30 Lambda functions. That's free. For the first year, for your Amazon account, you have a lot of free tier stuff. Still, if you are past that first year, it's only going to cost you a few cents, or not even cents, I think. EventBridge, 10 Shopify events is that very small number. And then step functions, 10 invocations, which also falls under the free tier. So the total cost for our first month will be, again, that small number. So let's say the next month we have an insane, awesome new sticker, and we sell 100,000 of them, or 100,000 of them, sorry. That will result in 300,000 Lambda function invocations, which again is still falling under the free tier. The first 1 million invocations are free. even if they won't, if you aren't in the free tier, it would cost you like 40 cents. EventBridge again, 10 cents for 100,000 Shopify events, and the step functions itself are going to be a little bit more costly, but still only $7.4, which is dirt cheap. The total cost of this for 100,000 orders is only $7.50 for the main component. So this is a very realistic price for this. There's even other ways to make this even cheaper, which will require some more work, but you can even get it cheaper. So yeah, the Rudy is very happy about this. And if we go back to the checklist, where the serverless function, so putting everything inside a Lambda function, already gave us these 2 check marks. Now with choreography and orchestration, we also have these 2. You have extensibility and maintainability. All your steps that are being done inside the process, let's say you want to send a Slack message, but also send an email, you just add another step to your step functions. The replayability part is something that EventBridge can do. If, like the Rudy did, all the orders over the weekend have printed a label with to do on there, you can just say to EventBridge, okay, replay all the events happening from this time till this time, and it will just replay all of them, send it all the way through our workflow, and reprint all those things with our new code. So also that is covered. So I hope that this kind of shed the light on how orchestration and choreography kind of goes hand in hand with a few extra mind switches with like item potency and stuff. How this can actually make your serverless architecture a success. Thank you. Are there any questions? Yes.
How will you handle it if you only want to print the labels and not send the messages again to Slack?
So did everyone hear the question? I'll just quickly rephrase it. So how do you handle it if you only want to do that one step, printing the label, and not do all the other stuff? Of course, if you want to do that, you can even simplify it more. Then maybe you should ask yourself, do we need step functions in this case? If we only want to do one thing, you can just say, instead of going from EventBridge to a step function, you can directly say, invoke this one Lambda function, for example, that will actually print that job. But if you want to make it future-proof, you can actually say, trigger a step function with that one piece of code in there, and maybe later we can just add some other functionalities. So for starters, you can just trigger one Lambda function if you want. Does that answer your question?
No, I'm thinking new orders coming in.
Mm-hmm.
So you want to keep the existing process.
Okay.
But next to that, you want to replay all the orders.
Mm-hmm.
And
So you mean
only you want to reprint the labels because they were wrong.
just only reprint the label instead of, then you can build something inside your step function saying, maybe with like just a toggle that says only reprint equals true or false. And then you, inside your step function, you can actually check that specific one. So let's say if you re-trigger it and you check a certain property on that event, if you see that it's from more than 1 day ago or something, you can say, let's not do all these things, let's only do this. So if and else statements, conditions are all possible inside step functions. So you can also do that. Mm-hmm.
How does step functions help with the distributed logging of the logs? Does it help? Or
The distributed logging, or
you mentioned in the beginning that the orchestration
mm-hmm.
choreography can help with actually getting the overview of the logs.
You can basically inside step functions, you can also inside the console of AWS itself, you can actually follow all the steps that are being taken. So you can see what goes in of this step, what comes out, all the logs of these specific Lambda functions themselves. There's also a thing, a service called X-Ray. If you send a specific correlation ID throughout the whole flow, you can actually use X-Ray to follow the whole flow of the event, even outside of step functions. If it goes to another service or to 5 other services, you can actually follow the whole flow and get a full exploded view of where goes my order and what happens to it. So there's a lot of possibilities with that.
And it's something you have to implement yourself and then pass it to correlation.
Yes, but you can use, like, let's say, the Shopify order ID for that, because you know it's unique. And if you tell X-Ray, this is my unique ID, then that's all kind of out of the box. Of course, you need to configure some extra services. Mm-hmm.
We saw that it's very cheap.
Mm-hmm.
But how to save yourself? Sometimes you see memes online. I broke my startup because a lambda function was
Mm-hmm.
taken out. So are there fail-safes built in? So your servers will shut down if there is no money.
Inside cloud providers like AWS, you can actually set cost limitations. You can say, okay, if this account is costing more than $200 a month or something, give me an alert, or actually stop this service. You can actually say, yeah, my Lambda functions, let them throttle and just don't do anything anymore. I have also done that once, just like you're testing some stuff in EventBridge and suddenly you're catching all events all over the place. But of course there's tools that can make you alert or actually shut everything down. But it's a good point, because that can happen very quickly because of all the asynchronous stuff that is happening. Something you need to keep in mind, yeah. Any more questions?
What's your development infrastructure when you build something like this?
Most of the times we really use an AWS environment to do all this. You also have things like local stack, which I don't really believe in, because it's very hard to mimic an actual cloud environment. You want to really use the real deal. So we like to actually make a full copy of the whole infrastructure, using infrastructure in code and all that stuff, yeah. All right, then I thank you all for your attention. Thanks.